there was a marching order. I was a part of that team. And we presented our report to the governor of Plateau State. And this was followed by a presidential initiative. What is the status? Have we solved the lead blight? Dr. Nyeka, I know you are in the forefront. What is the status? Is the lead blight gone? Where are we now? The lead blight disease of potato. Is it still, doing the harm? Okay, Amadi.
Okay, please, sir, just make it very brief, sir.
I'm aware that all the potato we eat in the south or east, southwest, they come from the core regions of Nigeria, Mambila Plateau, Obudu, and then Jos. Please, potato program, continue to work on this. Give us potato that we could grow in the south. Am I communicating?
Yes, sir.
Potato that we could grow in the south. This has been tried many years ago. Want them to repeat that, to go to that area again. Give us potato that we could grow in the south. I'm not expecting everything to come from Mambila.
Handpick like 2 and then note the rest.
It's just a response to the question on what we have done concerning the lead blight resurgence in Jos.
Okay, sir.
So, during that visit, sir, we gave 3 plan of action, short term, medium term, and long term. And we said in the short term, they should spray fungicides, and we recommended fungicides and how they should be sprayed. And then in the medium term, we promised to release varieties that have field resistance to lead blight, and we released 4 varieties in 2023. Okay, and then in the long term, we said we will release for that. So we are really working the plan we laid out. We're actually meeting those plans concerning lead blight.
Thank you, sir. Please just go straight to the point.
Okay. I appreciate all the questions and comments, and I'm happy, especially for the first question, Dr. Temperate crop. We are only trying to adapt them to environments that are similar to what their natural environments used to be. We evaluated these materials because the materials that were released in 2023, as Dr. Amadi has said, some of them were released on the basis that they are heat-tolerant materials. So that gave us the idea to evaluate them in some environments where the growing of potato is not natural. And we were able to come up with 2, not only Baban, as you saw, as you said. We had Baban and Kyo. Those 2 varieties performed very well, both in Obudu and in Mambila. So we can be using them in those environments for now, while we continue to work on getting potato varieties that will be strong enough to withstand those environments. So we know already the factor that is limiting them from performing in those environments.
Thank you.
For the soaking time, sir, we have taken the correction. We have to take soaking duration instead of time. Then the efforts to bring potato to cultivating them in this environment is just what I just explained now. The environment here is not natural for potato production.
Thank you. Thank you. Thank you. Thank you so much. Please, you can interact with them after now. Please interact with them. Thank you so much as we invite the Ginger program. And I will indulge the Ginger program to speak to the report. Don't read it. Just unpick. That will save a lot of time. You don't need to read. Just unpick. We are also reading what you are presenting. Thank you. Let's encourage the Ginger program. 20 minutes in all. You are welcome.
Good day, Mr. Chairman, my directors here present. I once again welcome you to the Ginger program. I'm going to give you what we have done in 2024 and our proposals in 2025. Next slide, please. So this is just our mandate. We are talking about, we have mandate of improving ginger and also developing marketing channels for ginger production. So this is our staff strength, our research officers, agri soups, and field workers. Then we have a total of 8 approved projects, and we have 7 completed, although some are still ongoing. Let's go straight to the ones we have completed. So one of the work we did was how to introduce exotic germplasm that will improve our genetic base. So in 2024, our team of breeders got some exotic germplasm from Kenya and from Morocco. So because prior to now, we only know we have only UG1 and UG2, and this is not good for breeding because you need to have a wide genetic base for you to have make good crosses and develop new varieties. So these new varieties were introduced by our breeders, and the take home here is that we have 2 exotic plants which we are going to evaluate for its trait potentials for further uses. So one of the work we did was we have seen that the ginger disease has been ravaging ginger, especially in southern Kaduna. So our team went on to look at the impact of this disease on the livelihood of people. As you can see from our table in the slide, we have the production has dropped from 16 tons per hectare to about 3.5 tons per hectare, which you can see in the board, which is not good for farmers. Yesterday, when we were doing the exhibition, we told farmers were asking how much is a bag of ginger. And a bag of ginger goes from at least 380,000 to 420,000. This is the cause. The cause is this is a complex fungal disease that has been ravaging ginger, and it has drastically impacted on food security as regards, and income too, as regards to ginger. As you can see, when they did their effect on ginger disease and livelihood, this is a loss due to variety crop losses was ranked highest, followed by potential death due to burden, because most of them had to borrow money and embark on this, but at the end, the result wasn't what they expected. So the take home here for all of us is we need a concise effort. If we want to address this disease, it's not only the research institute, mostly thank God we have a representative from the Ministry of Agri. The minister is here. So we need a concise effort if we want to address this ginger disease and get it nipped to the bud. If not, we'll be going round and round the circle and no headway. Next, we try to see how we can reduce the cost of production in ginger. And before now, we have used Panicum maximum, as we know, as mulch material for ginger. But our team tried to introduce sawdust to see how they can elevate the cost of production, because we know the cost of production is also add to the cost of mulching, add to the production in ginger, and also elevate the cost. So what do? They try to look at what is normally done. We're using Panicum maximum, which we use, and we use sawdust. So if you look at the table, just using sawdust, the normal mulch material, which we use as the SM, which is the Panicum maximum, is just about 11 tons per hectare. And when we use only sawdust, we give about 11.7 tons per hectare. But I want you to look at this. If you look at the combination of the poultry manure and the sawdust, it gave us about 20 tons per hectare. That's applying the sawdust as 10 tons per hectare. Then also, if you look at combination of poultry manure and the Panicum maximum, giving us about 18 tons per hectare, while poultry manure alone gives us about 17 tons per hectare. So what is the take home here is that poultry manure is essential for ginger production, and also we can actually reduce the cost of mulching, or more sawdust can serve as a better alternative and as our alternative to panicum maximum for ginger mulching. Well, let's go to our proposals. So the first one, I have threat profiling. Okay, this is talking about, I told you we have gotten 2 exotic plants, 2 exotic ginger. So the breeders are going to look at threat profiling and see how we can incorporate it into what we have. And at the end, we'll see how we can make do and improve our genetic base. So expected result is that top performing individuals identified for further breeding and release. And of course, you know, when we are through with this, we can even help to produce resistant varieties that can address the issue of ginger diseases we are facing now. Okay, the next one is the use of hormone biosynthesis in the production of high-quality ginger seed for yield increase and farmers' income in Nigeria. So the objective here is to evaluate the effect of indigenous hormone and also to assess the economic feasibility of using biosynthesis, enhancing treatment for sustainable ginger production. So we look at the next proposal, which is talking about evaluation of the effectiveness of eliminating mulching in ginger production by pre-sprouting. So this proposal is talking about, can we actually remove mulching stage in ginger production by allowing the gingers to pre-sprout before we plant? This is what it's all talking about. So the objective is to provide insight into whether pre-sprouting can serve as a viable alternative to mulching. The next we have is ginger legume synergy. This is talking about intercropping. A climate-smart analysis at the intersection of rhizome yield, soil health, and temperature management in Umudike Southeast. So it's talking about intercropping. How can you intercrop ginger and legume? So the objective is also to investigate the effect of a temperature regime on ginger production, ginger legume intercropping. The next one is the evaluation of the effect of different mulch technologies with supplementary herbicides for weed control and production of ginger in southern Nigeria. And southwest, okay, this is coming from our outstation in Nrcri, and they want to look at how they can use supplementary herbicides to control weed in ginger. The objective is to investigate the effect of different mulch technologies with supplementary herbicides for weed control in ginger production. The next is evaluating the effect of inorganic fertilizer on weed densities, ginger yield, and quality under different mulch regimes in Umudike. So the objective is to evaluate the effect of inorganic fertilizer on ginger yield and quality, to investigate the interaction between fertilizer application, mulching, and mulching on ginger yield and quality. Determine the effectiveness of different mulching materials for ginger production in the derived savanna. This is our outstation in Benue, Otobi. This is just exactly like what we have, the one they were going to repeat in Nrcri. This is what they are going to repeat, the same experiment in Otobi. So this is to assess different mulch materials, as you can see, plastic, cover crop, and also to analyze the cost effectiveness and sustainability of mulching materials for ginger production in the derived savanna region. The next one is development of a precise agriculture technique for targeted application of herbicides and biopesticides in ginger rhizome root rot management and prevention. So this is just to avoid discriminate application of herbicides and biopesticides. So that's targeted, that's what they are proposing here. So the objective is to assess the distribution of and severity of root rot disease in ginger, to evaluate the efficacy of precision agricultural technique in managing rhizome root rot. Investigating the role of environmental factors in the epidemiology of rhizome soft root disease of ginger. So this is what they look at. The objective is to identify the characteristic key environmental factors that impact the incidence and severity of rhizome root rot and disease in ginger, to assess the impact of different environmental conditions of pathogens in and virulence in survival of ginger. Next slide is evaluation of the effect of natural clean biofertilizer. This is on the soil properties of ginger, disease mitigation, and cultivation. So they want to, there's a natural clean biofertilizer, I think, coming from a company. We want to evaluate it and see how effective it will be in controlling growth disease mitigation in ginger. So one of the objectives is compare the performance of two ginger varieties we have, Umogene 1 and Umogene 2, on different application methods. We have to apply on the seed, the foliar, the soil, and see how it will address disease in ginger.
Thank you. You should be
Control
rounding
of
you should be rounding up, please.
Yeah, I will round up, sir, in 2 minutes, sir. Control of extreme species affecting ginger production in ginger. This is the objective is a more practicable and sustainable control technique to curb rhizome root rot in ginger production. Ginger identifier. Then the next row is this is just more like a literature review where the researchers or the team want to look at what biotechnology tools has been in place in mitigating this or addressing the issue of ginger root rot. So it's more like a literature review. Evaluation of the effect of eco-friendly. Yeah, the team here wants to look at using some biofertilizers to address some diseases of ginger, fungal disease of ginger in Southern Kaduna. So to assess the potency of eco-friendly soil and soil treatments in controlling ginger fungal disease, to ascertain the effectiveness of rhizome yield of ginger using eco-friendly and soil treatment. Now, this is, I think this is our last slide. It talks about the engineer in their team. They want to look at, preservation has been a very serious problem in ginger. So most of the times, when we harvest, by the time you go to planting, you must have lost about 30% of your seed. So how do we preserve it so that we maintain at least 90%? Since we cannot effectively go for irrigation farming. So so they are proposing designing a cooling system that we can, not only for ginger, but for other root and tuber crops, where we can preserve our tubers for the next planting season. On that note, I say, merci beaucoup.
Thank you so much. Thank you so much for good presentation. You have preempted me. I wanted to say, where is mechanization here? And you put it last. Thank you for that. And there is something I want to ask you. You are saying they want to. Who are the they? Okay, be thinking of that. Do we have questions? Thank you so much. 1, 2, 3, 4. Thank you. Thank you. Yes.
Let me thank the presenter for the work well done and well presented too. I want to make a comment in respect of the introduction of exotic ginger varieties so as to increase the genetic base of the crop. I'm aware that a similar exercise was embarked upon in the recent past, during which time we got varieties like Rio de Janeiro, Maran, and Wana Local and all of that, Himachal Pradesh and all the rest of them. Today, from the way you are sounding, it does appear we have lost track of those varieties. I wonder why. And if now you have decided to import more exotic varieties, have you put in place mechanism to ensure that what happened in the past, whereby we lost all those varieties, we don't encounter that again? Otherwise, I would consciously suggest that you first of all look at the program itself and find out what you can do, so that when you get these exotic varieties around, you will have the capacity to conserve them and carry out all your studies. It doesn't make sense after studying, after spending money, getting all these things, after a few months or a few years, they are lost completely. We lose track of them. That's number one. Number two, On your work involving sawdust, I was waiting to see if you did the chemical evaluation, the analysis of the sawdust used. I am sure you know about the CNU ratio and the effect it will have. I hope you are not going to end up increasing the CNU ratio of the soil, whereby it will now go affect negatively the eco-balancing of the system. So I would suggest, and humbly too, that you look into that critically. Secondly, how do we ensure uniformity in the application of the treatment? Because I believe at the end of your study, you are going to make a recommendation for farmers to use. Where we collect this sawdust, there isn't any uniformity. Sawdust is made up of trees or wood from different age groups and so on. Do you think that use of that material is a good thing for you in view of the fact that you don't have a control over the property of the dust you are going to apply? Thank you very much.
Again, thank you, Mr. Chairman. Every research we are doing here, we are considering the end users. Now, in the mulching experiment, mulching work, I remember some years back, I think during the time of late Dr. Ene, we had used plastic material for mulching. If we come up now that plastic material is good enough for mulching, is it feasible? Is it available? That was why it was discarded, feasibility and availability, using mulching material, unless for experimental purposes in the station. Otherwise, how many farmers can get that? Thank you.
Yeah, Mr. Chairman, for evaluation of sawdust, or all the mulching proposals made, I would advise the presenter to go back to literature. Go back to literature, go back to annual report. They are all there. Okay, and again, storage, the last thing he presented, he should equally go back to literature. Dr. Rene did not use any machine, any cooling machine. He stored in pits. And all these things are documented. Go back to literature, please.
Yes, thank you.
Okay, thank you, presenter. My own is, so many years ago, we did evaluate ginger production across Nigeria. And we found out that ginger does even better here than in southern Kaduna. What happened? The only problem we had then was drying and marketing it. What have we done so far? We just abandoned it or something. And if you go back again, even the problem of mulching, we said that ginger is essentially a shade-loving crop. So if you go to cocoa producers and they plant their ginger under the cocoa trees or oil palm trees, they will do very, very well. They don't even need mulching. So, like they were advising, go back and then see what you can add to what is already known.
Thank you, sir. The last, please, or not the least.
Chairman, sir, I really want to ask, in some of these researches you intend to carry out, you talked about the team you use for the research. My question is, members of this team, are they totally drawn from the institute, and can people outside the institute, like postgraduate students or other persons so interested in this research, can they be co-opted into the team? Thank you.
Thank you. Please just go straight. You can handle 2 or 3 because of time.
Okay.
And then note the rest.
Okay, thank you. Dr. Dinwogo, your issue on SCN ratio have been noted. Let me start from the last. The team, yes, the Institute is welcome to collaboration. So we are welcome to collaboration. So we are open to collaboration. That is the intent in research now. Professor Chilaka, yes, you know, weather changes, climatic changes, there's changes in weather. The experiment done some years back may not be the same now because of climatic changes. And I think we need a cooling system in the Institute, if not for ginger, but for other root crop. I'm not disproving you, but you know what we experience with climatic change now. Yeah, Dr. Dio Wog, you talked about the exotic plant. Yes, right now we have UG1 and UG2. And I assure you that this, because I have a team, we have a team of dedicated breeders who are going to make sure that these exotic plants, if proven beneficial.
Thank you so much. Thank you so much. Thank you for a nice presentation. Can we encourage him? Can we encourage him? Thank you so much. Thank you. The last person, that is Taro and Cocoa Yam program. You've seen how this man presented his own without reading through. Just pick to it and pick some, and then we'll read the rest. You have 20 minutes in all. Please.
Thank you, Mr. Chair, and welcome everyone to the Giant Crop Program. This is the outline for my presentation, and I want to promise the chairman that we'll run fast. Because of time, we will not go through these briefs on taro and cocoyam. Yeah, about 10 works were proposed, and about 8 of them were duly carried out, and we dropped one for some reasons. So I will present, first of all, the breeding works that were done during the last season. So the first one is on crossing block for flower production in parental population of Tenia in Umudike Rainforest Agroecology of southeastern Nigeria. And this work sought to evaluate the flowering ability of selected Tenia cultivars treated with gibberellic acid, and then to also study the flowering behavior co-intensity of the crop. And after the evaluation, we saw that the first 2 assertions were high, looking at the number of flowers per plant, as you can see here, and then the flowering intensity also were very high. And we're now concluding that these assertions will be ideal for parental crosses in Tenia due to their those potentials that we have already mentioned, requiring timely hand pollination within a short 2 to 5 months of flowering period. The next one is a crossing block for true seed production in parental population of taro for new taro progenies in Umudike Rainforest Agroecology of southeastern Nigeria. And the objectives are to determine the number of crosses made for fruit head generation, to determine number of fruit heads with mature fruit berries per family, to determine the number of seeds generated per family, and to determine the responses of these parents to taro leaf blight infection. And after the evaluation, we can see that the clones, the second crosses that were done here, gave us about 154 seeds. And we're hoping that these 154 seeds developed will be tried under seed evaluation, and the traits will be determined quantitatively to select new taro genotypes for wider adaptation. And the lessons, the take-home lesson here is a hybridization block can be set up in off-season as an escape to TLB attack. The next is effect of time of planting and rates of gibberellic 3 acid on pollen production and viability of taro and cocoyam assertions. And the objectives were to determine the appropriate time of planting for flower production, to to determine the best concentration of gibberellic acid application for flowering, and to check for pollen production and viability of the assertions. And after the study, we have this take home that early planting is recommended for, but however, late planting to escape TLB infection, which is prevalent during the rainy season, may be necessary, but should be complemented with the use of irrigation. The next is the clonal evaluation of new taro genotypes for growth and response to taro leaf blight disease in Umudike South, Eastern Nigeria. And the major objective was to select genotypes with high vigor and immune resistance to major biotic stresses such as TLB disease. And after the study, we had this major take home that there was significant variation in plant vigor among taro clonal genotypes, with high vigor lines potentially offering increased yields. And several genotypes showing strong resistance to TLB were identified and selected for preliminary yield trials, with all the added benefits and the income outcomes of the stakeholders. Sorry. Okay. Yeah. The next is a preliminary yield evaluation of taro hybrid genotypes for yield and low sucker yielding attributes in Umudike. The study sought to select the genotypes with low sucker production and also to select high combs and comers yielding taro genotypes resistant to taro leaf blight for adaptability trials in other agroecological environments. And after the evaluation, we have this take home. Taro genotypes with fewer suckers, superior yields, high comb and comel counts, and strong resistance to virus and taro leaf blight were selected for advancements, offering suitable yields and durable TLB resistance through genetic improvement. Okay. This is an advanced yield trial of taro genotypes for high yield of combs and comels with morphological attributes for commerce potential. And the study sought to select taro genotypes with high yielding combs and comels with tuber morphological attributes for commerce potential. And then to select the taro genotypes that are free from comb rot disease. And here we could see that most of the genotypes that were used for this study had greater number of combs and comels, than the pointer is not showing, than the checks that we have here. And so the take home here is that the selected taro genotypes which show superior yield and market appeal, offering farmers improved TLB resistant varieties be advanced for further evaluation. Sorry. Now, this is a uniform trial of taro genotypes for commercial tuber production in Umudike rainforest agroecology of southeastern Nigeria. And the objective of this very study is to select high-yielding taro genotypes for commercial cultivation, to select genotypes with marketable attributes that command market value, select genotypes resistant to major taro pests and diseases such as TLB. TLB has been one of the major problems of taro, and we are working to make sure it's been handled. The take-home is the selected UYT genotypes, which includes this SM136 UYT21/028 with a yield of 0.1 tons per hectare, which surpassed both the check cultivars and the grant mean, making them suitable for further evaluation and potential export markets, benefiting farmers, especially women. through increased cash income. We are also factoring gender in this study.
Can you go to proposal, please?
Okay, sir.
Please.
Okay, I just have one report on agronomy, and this on exploiting the use of organic foliar fertilizer in controlling cocoyam leaf blight disease. And the objectives were to determine the effect of foliar organic fertilizer on yield of taro, and then to ascertain the effectiveness of liquid fertilizer in controlling taro leaf blight disease of cocoyam. And after the evaluation, we have a major take-home that Boost Extra foliar fertilizer is recommended for more yields, while Black Diamond recommended for taro leaf blight control. Chairman, sir, do I go over to the proposals? Okay. Yeah. For the genetic improvement in our 2025 proposals, we have the first activity, taro germplasm collection, evaluation and characterization of taro species for pre-breeding development of new taro cultivars. The objectives will be to collect as many taro accessions as possible across and beyond the nation's borders to broaden the genetic diversity of taro as food crop, to improve the adaptability to different environmental conditions and resistance to pests and diseases. The third one will be to conserve breeding materials of native species that has nutritional or industrial use. The fourth one will be to evaluate and characterize accessions that will economically help the nation to increase productivity and sustainability of taro production. And the last, okay. The next is development of new progenies of tenure for high-yielding cultivars through genetic recombination of parents in the crossing block. And this work seeks to develop a new tenure progenies of cocoyam through botanical seed production and to develop the tenure through seeds for germination into seedlings. And then we have other objectives as listed there. Next is evaluation of tenure, accessions of cocoyam for yield adaptation and biotic resistance across diverse agroecologies for documentation and registration as variety in Nigeria. The objectives are stated there: to register selected tenure accession of cocoyam as variety in the country. I will spare you the remaining. Okay. This is an on-farm farmers participatory variety field evaluation and culinary quality assessment of taro accessions for official release as variety for commercial taro cultivation in Nigeria. And the objectives are stated there: to test the performance of promising accession under farmer growing conditions and researcher farmer management, to test farmers' acceptance and rank preference of the varieties for yield and yield component attributes. This will actually help the breeders breed the demand-driven cultivars. Screening of tenure cocoyam for symptom-free baboon virus disease and comb rot disease in hydromorphic acid utisol of southern Nigeria. The objective here is to select high root yielding cocoyam genotypes, symptom-free from baboon virus disease complex and comb rot disease. Also to select genotypes that can withstand the attack of major pests and pests attacking cocoyam in the field, such as yam beetle, yam leaf beetle, crickets. And then to select cocoyam genotypes that are high yielding and mist resistant to biotic stress. This is establishment of crossing block for botanical seed generation, for the development of new generation of taro progenies. This preliminary yield evaluation of taro hybrid genotypes for high yield and resistance to major biotic stresses of taro in the taro growing areas of the country. This is an advanced yield evaluation of taro genotypes for high tuber production and selection for traits with export potential in Nigeria. This is a uniform yield trial of new taro genotypes for yield and yield stability across 3 cocoyam growing states in Nigeria. This is a smart way of handling, that's the next proposal, smart way of handling seed germination and seedling management of delicate root and tuber crop seeds. And the objectives are stated here. Next is to understand the mechanisms and phenology of taro cocoyam flowering and botanical seed development for efficient genetic improvement. The next is heterosis and combining ability among promising single cross hybrids in taro for major growth and flowering traits. The next is development of molecular markers for disease resistance, flowering and yield improvement in taro. Is enhancing taro yield and disease control with plant growth promoting Rhizobacteria inoculum. This is evaluating taro for analgesic properties. So the next is optimizing post-harvest storage of taro and tenure in Nigeria, an integrated approach. Assessment of, okay.
Can you just go through, you see how for that? Okay. Yes, yes. 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 Yes.
So I want to talk about this. Okay, okay.
Just run through.
Thank you for listening.
Thank you. Thank you so much. Honestly, you can't finish within 20 minutes, and you tried your best. Yes, we have questions, and then, yes, contributions. We start from here. No, we start from former director, please. Former director, let's start from former director here.
Thank you so much, Coordinator Kokoyam. I have only one question. How far have you gone in solving the taro leaf blight? How far have you gone? Thank you.
Mr. Chairman, mine is not a question, it's an observation, which more or less runs through the programs that I've presented. Early enough, we had Dr. Mrs. Beniro make proposals on genetic resource program. But most of the programs get into evaluation, genetic resources. Then what is Mrs. Beniro's program all about? I think these people require to go back home and realign and know which one goes where. That's my question. My observation, please, not question.
Thank you very much. My question and observation is in line with my simple layman's question is, the research you are carrying out, are they farmer problem driven or doing just applied research? Are the problems coming from the farmers? I know in 1982, I carried out a survey of Eastern states on cocoyam production and came back to the institute pointing out the major problems
the farmers were facing. That was storage. And that was the basis for the research within that period, and there are documentations. Around 2009, we have this disaster disease, leaf blight, almost wiped out the cocoyams we have. And in line with what the former ED said, how far? And it's important that I know that we have Panadol, we have paracetamol that are developed, but they're doing research to find out more powerful ones, that if you take it one tablet instead of two. I think that would be the area we look at, research progress, improving on what has been done, not going back to do what exactly had been done 5 to 10 years ago. Thank you.
Yes.
Thank you, Mr. Chairman. My own is an observation that runs through most of the programs that I've presented today. I seem to have observed that most presenters don't include soil test results in their field trials. I don't know whether this is institutional policy or what. Even though I did uniform yield trial and all of that, the soil is the basis for our agricultural practice. We need to have an understanding of the physico-chemical properties of the soil, where planting is being done. And it is only when this is done, when the picture is graphically captured, that you'll be able to appreciate whatever yield advantage you get at the end of the day, and be able to come up with whatever technology you want to suggest. So I don't know whether there is a conspiracy against soil in this place, because all the programs, none of them is including giving us a picture of soil test results ever before the experiment was done. I would suggest that this be looked into critically, because it has a great influence. Secondly, I want to also say that cocoyam is an important crop, especially for diabetics, we know. Is it possible for us to begin now to formulate trials that will highlight the supplementary value, the use of cocoyam in formation of supplements? People formulate all manner of things now to cure certain diseases of human beings.
Thank you.
Can we collaborate with other organizations to come up with this so that we begin to actually potentiate the relevance of our crops in different dimensions?
Thank you, sir. Thank you, sir. Please just respond to like one, not even two, and note the rest. Just rank them, and then the highest in rank.
Okay, sir.
Just respond.
Luckily for me, a good number of them were observations that will be considered after now. So they are well taken. The question on how far we have gone on taro leaf blight problem, sir, much has been done, and just some few years ago, one of us had identified a particular gene that is responsible, so she will need to, validate the result she has gotten, and then we'll take it off from there. So progress is, being made as touching and tackling taro leaf blight problem.
Thank you.
And then other observations we have taken note of.
Thank you.
Especially the soil aspect. Thank you very much.
Let's encourage him. Let's encourage him. Thank you so much. Thank you so much. It has been wonderful. My observation is that the mechanization aspect of all these programs, there is nothing reported except the ginger, which was just an appendage. We can focus on the scientific, but without the mechanization, the encouragement for taking it up may not be there. The drudgery that is involved will discourage even people in in large scale. So please, the mechanization aspects. I don't know whether it's a program in research or it's just running across all the programs. Please try and be visible in some of these reports. I wish to thank the organizers, most especially Dr. Tessie Madu, for conscripting me where I sat down to serve as chair. Is a privilege and an opportunity which I'm not taking lightly. Thank you so much. Acting Director, I appreciate. Thank you.
Please, can we put our hand together for the chairman? He has actually done excellently well, helping us to manage the time perfectly. Thank you so much, sir. By our program, we were thinking we'll take lunch, but remember that we must finish today. So some people are advocating, are we going to continue? But we must take lunch. So they should quickly check if we can do that actually in 30 minutes, so that we can finish and we will not have to go into the night. But how many programs do we have remaining? Every program coordinator, please make sure you've uploaded your presentation and look for how you can summarize it. Over to you.
Yeah, it's food o'clock now. 1 hour for food, so that we can come back and round up. Just like we did yesterday, we have also distributed tickets. Our very distinguished people will lead them to the bus to go to have their lunch the other way, and the rest of us will stay here. Please, can we start now? Lunch starts now.
ain't get it right, but me like I'm a she up on me. I know my actions got the worst up on me. Look like the devil take this moment from me. And I thought follow the gas, now you fast, now you take my apple. If I ask, see me, I lose on you. My mistress, take all my money, I'm broke. And I thought follow the gas, now you fast, now you take my apple. If I ask, see me, I cheat on you. My mistress, take all my money, I'm broke. Why the girl? Feeling me, I'm like that before my time. Feeling me, I'm like that before the sunset shines in the morning. Get me fire. Why the girl? Feeling me, I'm like that before my time. Feeling me, I'm like that before the sunset shines in the morning. Just before you why the girl? Feeling me, I'm like that before my time. Feeling me, I'm
Dr. Kadrumba and Dr. Patience, the rapporteurs, please can you go upstage? Thank you, Professor Sawala. I'm sorry, thank you. I know you forgive me, I'm your sister.
We have cassava, we have sweet potato, we have cassava, we have sweet potato, we have opportunity.
Cassava program, are you ready? Please come up stage. Dr. Favor.
You stay here. Make it fast, you know? Noted, noted.
Yeah.
So be strict on time. We are going to be strict.
Professor Sawalam, please. We are running late. Just be strict as ever on time. So your time starts now. Coordinator is already started.
Okay. Thank you very much. Coordinator, I think you can go ahead and start. We're told we have just 20 minutes up to that? 15 minutes. So please, start.
Okay. Good afternoon, Mr. Chairman. Good afternoon, my directors, assistant directors. Good afternoon, ladies and gentlemen. My name is Dr. Favoyewa Okawu, Coordinator Cassava Program. So I'm here to to present the annual report, Cassava Program, and also the proposal for 2025. So this is the outline, achievements and lessons learned, outlook for 2025 cropping season. Two white high-yielding cassava varieties, Omocas 55 and Omocas 56, were released in 2024, being supported by RTB cassava breeding projects. Then we have this collaborative project with AATF for high-quality cassava flour, China Nrcri joint research project on the construction of cassava green and efficient production base in Nigeria. So we'll be able to develop cassava breeding manual that contains standard operation procedures to facilitate daily breeding activities. The annual reports. Establishment of crossing blocks and generation of botanical seeds for genetic improvement of cassava. The objective here is to develop F1 segregating populations, and from the results, result shows that we are able to develop over 23,000 seeds, and the key achievement is we were able to develop F1 segregating population that will be advanced for further evaluation. Screening of farmers preferred local cassava cultivars for resistant gene against cassava bacterial blight. The objective is to determine the level of resistance of the local cultivars to cassava bacterial blight using disease severity indices. So the result shows a variation which was highly significant for CBB incidence and severity. And from table 2, we can see that at 6 months after planting, we were able, when we scored for disease CBB severity, we were able to get cultivars, these local cultivars that were resistant to cassava bacterial blight. The same thing is applicable at 9 months after planting. So our key achievement is that we identified resistant clones from the local cultivars with respect to CBB. So what are we going to do next? We are taking them into our crossing blocks to introgress to introgress the gene into susceptible cassava varieties. Genetic gains for yield and disease resistance in cassava varieties developed from 2005 to 2022 in Nrcri Umudike. The objective is to quantify annual genetic gains in cassava yield and disease traits for selected cassava varieties released between 2005 and 2022. The thing here is that as a breeding program, we need to know our strengths and we need to know our weaknesses. Using this genetic gain, we know whether we are improving on those traits that we are really evaluating before release. And when we find out that, well, if we identify our strengths, it is a good thing for us. When we identify our weaknesses, we need to improve on it. So the result shows that from 2005 to 2020, there was drastic reduction in CMD severity. The same thing is applicable to CAD severity from 2000 to 2020. So the key achievement is substantial genetic gains were made for resistance to CMD and CAD, and 4% yearly between 2005 to 2024. Lessons learned. We realized yearly genetic gain higher than previous study by Okechukwu et al. 2008 of varieties released from 1970 to 2000. The reason for this drastic reduction to CBB and CAD is as a result of we now have improved technologies such as marker-assisted selection, and even in phenotyping, we try as much as possible to screen out susceptible cassava genotypes, genotypes that are susceptible to CMD before going for release. Effects of water hyacinth manure and NPK fertilizer on the growth and yield of cassava. Water hyacinth is a weed that is found in river, and it causes water pollution, and it is not also favorable to animals that live in the water, such as fishes. So experts are saying that one of the ways of utilizing this water hyacinth is to convert the biomass into organic manure. So we decided to carry out this research work to determine the nutrient composition of water hyacinth and to examine the effects of water hyacinth manure on the growth and yield of fertilizer. So the result shows the mineral composition of the dried water hyacinth plants. The key achievement is mineral elements of dry water hyacinth was successfully determined, and we were able to obtain high organic manure, organic matter of 42.6% and organic carbon of dry water hyacinth, indicating good potential for the use in the improvement of soil health and fertility. Levels of adoption of good agronomy practices on improved cassava varieties in Anambra State, Nigeria. The objectives are to identify the extent of adoption of cassava varieties released in the years, to estimate the levels of adoption of good agronomy practices, to identify the constraints militating against adoption of good agronomy practices. So the result shows that majority of the farmers adopted most of the agronomical practices except fertilizer application and ridge making using tractor. Reason being that high cost. The reason for this is that they don't have the money to buy fertilizer and also to hire tractor to reach their fields. Lesson learned, majority of the farmers adopted most of the agronomy practices very well, except fertilizer application and the use of tractor. Registration and release of 2 cassava varieties, Omocas Renewed Hope and Omocas 56 Biggie, for processing and industry market segments in Nigeria. So this happened in October last year. Nrcri, in collaboration with IITA, released these two white cassava varieties. One is for processing market segments. That's a renewed hope, which is very good for fufu and gari, while the other one, industrial market segment, which has high starch content with mechanizable architecture. So these varieties, before they were released, they passed through so many breeding. Okay, so let me just summarize. Release of two high-yielding new varieties for processing and industrial market segments. So why were they released? Both varieties consistently demonstrated high yield, adaptability, disease resistance, and favorable processing and industrial qualities. So for renewed hope, you can see the fufu yield, gari yield, the swelling power, because now people are looking out for gari. When you pour water inside gari, it will be swollen up so that you have enough quantity. Then for Umukas, that's Biggie, the one that was released for industry market segments, you can see the dry matter content, starch yield of 30.43%, mechanizable plant architecture. Proposal for 2025. Genetic improvement of cassava. The activity ranges from establishment of crossing block to registration and release. The objectives are to develop high-yielding, good food quality taste and disease-resistant genotypes, to evaluate these improved genotypes and select the most promising types that meet different demands, to register, release, and deploy new varieties for commercial use. Characterization and phenotypic evaluation of some farmers' preferred local cassava cultivars for breeding value and agronomic traits. The objectives are to profile quality attributes, breeding value, and other important agronomic traits possessed by the selected local cultivars of cassava, to carry out morphological characterization of the selected cassava accessions. Characterization of F1 early maturing cassava genotype for food and industrial purpose. The objectives are to evaluate the agronomic performance of the F1 early maturing cassava genotype, to assess the physiochemical properties of the cassava roots, to determine the sustainability of the genotype for food and industrial purposes. Lastly, to identify the genetic markers associated with desirable traits in the genotype. Comparative analysis of weed management methods on weed infestation using herbicide and hand weeding in cassava. The objectives are to examine appropriate pre- and post-weed control methods that can minimize weed infestation in cassava field and give an optimum root yield, to determine efficient and sustainable weed management to enhance cassava yield. Management strategies of termite infestation affecting cassava farms in Iyanya Outstation, Abuja, Nasarawa. The objectives are to determine the level of damage done by termites in the cassava farmland, to adopt the best control mechanism for sustainable farm productivity. Screening of cyanogenic glucoside levels and glycemic loads of selected local cultivars of cassava for breeding and crop improvements. The objectives are to identify local cultivars of cassava with safe levels of cyanogenic glycoside and low glycemic load, to profile the cyanogenic glucoside levels assay, assay the proximate composition, and calculate glycemic loads of the cassava cultivars. Characterization of ash content and estimation of percentage daily value of yellow root cassava varieties from 2011 to 2022. The objectives are to identify ash content components of yellow flesh cassava varieties roots from 2011 to 2022, to estimate percentage daily value of beneficial components identified, to determine the cost effectiveness of the daily value. Knowledge status on disease control practices among cassava farmers in Southeast Nigeria. Implications for extension delivery. The objectives are to identify the major cassava diseases in the study area, then to determine the effects of the diseases on cassava production in the study area. Farmers' adoption and utilization of improved cassava varieties in Abia State, Nigeria, to ascertain the perception of the farmers about the newly released varieties, to identify the constraints working against the adoption of the newly released varieties. Thank you for listening.
Okay.
Thank you. You just saved us 2 minutes. Please, can we have 1 or 2 contributions to this? Any question in the first place? Does anybody have any question on this row? This row? This row? The last one? It's okay. Okay, one there. Please, let's have at least 1 question. Indicate your name, please, for the rapporteurs.
Thank you. My name's Sir Christopher Mwabudo Nwanevu, CEO, Mwabudo Agrosis and Depots Company Limited. Our problem, our need is always, where do we find your research product? Dr. Kakbo, you mentioned from your presentation that you were able to release Omocas 55 and 56 last year. Are they available for the seed companies to pick and continue with the multiplication process? Thank you.
Not sure we will take more questions so that the other programs can also have this thing. Please, can you just respond to that and then we can go to the next.
Okay, okay, sir, you are asking if they are available. Yes, they are available. So you can source these materials from Nrcri, Umudike. You can source these materials from Umudike Seed here in Nrcri. You can also source this material from our partner, International Institute of Tropical Agriculture. Maybe later, I can also give you my phone number so that you can call me. I can always help you out. Source for the material.
Thank you very, very much. Please, can we give a round of applause? Yeah.
Thank you so much, Dr. Favor, Cassava Nigeria. Her name is Dr. Favor Okakpo, in charge of Cassava program, in charge of Akpu program. Thank you so much, Professor Damian Asawalam, for standing in for Dr. Nto. I will now call on Dr. Tay, who is representing Dr. Nto, to take over. Please come up stage. Yes. The next program is a sweet potato program. He's already here.
Good afternoon, the chairman and great scientists. My name is, okay. Sorry? Oh, sorry. Okay, yeah, technology. So I stand to present for sweet potato program, and I will quickly run through this because of time. So we'll be talking about the achievements, the annual reports, and also the proposals. So these are the key achievements for sweet potato in the year 2024. We were able to get to the point of releasing new varieties, which we hope we will be able to do this year after so many years. And then our studies on fertilizer has new insights. Our extension work helps us to see the gender roles, and then the seed system. We have taken all of this in our stride. So for the breeding, we are dealing with two market segments, so the boiled and the fried, and then the nutrition segments. So all our breeding work actually are here. We undertook all of these works in 2024, but we will be reporting on the crossing block, and that is very critical for us because this is where we generate new breeding materials. Suffice to say that in our hand control crossing, we were able to generate 433 control cross seeds, and these materials they were developed for the nutrition market segment. And for the open pollinated, we have generated about 11,000 seeds. So in all, we are having close to about 12,000 seeds that we'll be dealing with this current year. For our seedling evaluation work, we tested 307 genotypes, and these are the segregation for the flesh color. And when you look at this, so we have the purple flesh and the orange flesh. The two of them actually more than half of the population. So which means that our nutrition pipeline is very active, and in no distant time we will be we should be releasing new varieties of OFSP and purple flesh sweet potato. And for that same population, segregating population, we are glad to say we have quite a number of them that are also having marketable root yield, and that is very key because sweet potato segregates a lot for different things. For the clonal evaluation trial, we have about 90 genotypes that will be taken into the next phase in 2025. But when we profile them, you see that the yield is even up to, the yield is up to 66 tons per hectare, and the range is between 10 tons to 66 tons per hectare. In our nationally coordinated trial, because like I said, we're trying to release new variety, and which we hope that this year we'll be able to do. Suffice to say here, in the last column here, we have, against all odds, we have about materials across 6 locations, 18 tons per hectare, 17 tons per hectare, all above the national check that is giving us 13 tons per hectare. And these materials are good for frying, and they are also good for, they are good for frying, and they are also good for boiling. And these are the key market segments that we are breeding for. Okay, so this is the sensory, and then I don't know. Okay, for the agronomy, now the key note speaker talked about the fertilizer use, and this is very critical. When we look at what our results here is saying, is that we have to start profiling for our key varieties what kind of fertilizer will, blanket fertilization will not work. So here we have seen with this result that when you add too much nitrogen, 87, there's yield depression in TIS 87, while buttermilk is good for increased nitrogen. And when we look at this result, when for nitrogen contribution rate, what nitrogen is contributing to buttermilk is about 28%. For 87, it is actually depressing your yield. Potassium is, when it is not available in right quantity, is depressing buttermilk yield. Whereas is very phosphorus is very key for 87, and potassium is key also for 87. I think this is opening up our idea about fertilizer use so that we just don't continue to pour in fertilizer into our farm. Now for the seed system, this work is about the adoption of the technologies that we have sent to farmers over time on how to conserve sweet potato vines over the dry season. So when you look at the triple S, the net tunnel, the open field, and the water stored area, which is the Fadama, we see here triple S, about 87% of the people never even tried it. 86% tried and dropped net tunnel, and 100% were aware of open field and the water stored area, and they've retained it largely. And when we look at the reasons also why they are dropping triple S, we see that the key reason is that it competes with the edible roots. Those same roots you want them, because the triple S, you make use of the roots, is competing with the edible roots for them, and also at the time of doing this, is also not favorable to them. For the net tunnel, it is maintenance and the drudgery involved. And for our socio-economic studies, we have seen here, this is the gender differential in the adoption of OFSP in Southeast. We have seen, we can see here that while UMUSPOR 3 is, adopted between male and female in the same way, UMUSPOR 1 and UMUSPOR 4 has differential ways that they adopt them, and that is in a significant way. For the physical, I think this is about the last one here, the physical-chemical changes in the quality of fertilizer grown. I will have dropped this, but I really want to show this, because when we look at poultry manure, fertilizer, we see that at 600 kg per hectare, our recommendation is 400 kg per hectare, and we see that 600 kg per hectare is actually way better than applying 400 kg per hectare. Of course, this should have come with economic analysis also, but this is informing some other studies that we'll be doing this current year. Now, people have been asking, does it cause, what's the relationship between fertilizer application and rate of decay? And this is the answer. Well, in a nutshell, this is the higher the quantity of fertilizer you apply, then the faster the rate of decay. That is in Mother's Delight and also in TIS 87/0087, but in 87 does not decay as fast as in Mother's Delight, and that is the end of my annual report. I should quickly go. Thank you very much. So for our breeding, we'll be having all these activities. Like I said, our breeding target is to develop new varieties that fit into the boiled, the fresh table, sweet potato, and the nutrition profile. So all these activities, hybridization, seedling evaluation, clonal evaluation, preliminary yield trial, all of them are tailored towards achieving this objective. And so we will be having a recalibration of our sweet potato plant density and fertilizer recommendation for optimum yield and root qualities under changing climatic condition. And the objective of this is we have all these recommendations are over 2 decades old, and do they still hold? And we have seen one result that show that they may no longer be holding, and so we want to investigate that. We want to also do the comparative evaluation of the different organic, compounded organic fertilizer in the Otobi area. So the objectives will include to assess the effect of the different these compounded fertilizers are there, so we want to test them and see how they work. Also, the effect of weed treatments on growth and yield of sweet potato in the derived savanna agroecological zone of the Southwest. This work will be done in the Southwest at our outstation over there, and it's just to see the effect of weed management strategies that will be okay for them. Influence of storage duration of sweet potato vines on germination, growth dynamics, and root yield of sweet potato under humid agroecology. This is about ratooning. How long can you ratoon? When you cut your vines, how long can it stay before it depreciates so much that it affects your yield before you plant? And we think this is very important because of seed movement. Seed system, another proposal is for adaptation of SAH to the multiplication of different sweet potato genotypes for high quality vine production. SAH is being used in cassava, in yam now, and in sweet potato also want to adopt it and then see how we can use it to generate high quality planting materials. And also farmers' participation in sweet potato seed system, exploring the gender inclusive strategies for enhancing seed quality and market access. So we want to really do gender disaggregation and see how gender influences the seed system so that we can know how to include gender in our work. Thank you very much.
Thank you, Mr. Presenter. Okay, because of want of time, we are going to take, okay, I already see 3 hands up. So we're going to give these 3 people the opportunity to ask or suggest better ways this group can improve the work they are currently doing. Yeah, 1, 2, and 3. I don't know if there's any other person over there. In the absence of it, just go ahead, sir.
Thank you so much. A lot of work has been presented on application of fertilizer in sweet potato production. My worry is, what is our take home now? One of the graphs shown is that the higher the fertilizer application, the more the roots rot. This is very important for farmers. Like in yam, some farmers refuse to apply fertilizer. That fertilizer applied in yams rot quickly. So what is the practical experience that we should take home on fertilizer application on sweet potato production?
Sir, please, could you please tell us your name so that...
Dr. Wonzo is my name. Okay. Retired, but not tired.
Thank you. Are you taking note? Yeah, the next person, please.
Yeah, my own name is Echendu TNC. Retired, not tired. Former coordinator of sweet potato program. So mine is just a simple question. So I noticed that in varieties for multi-locational trials, some of the names were PGA, that kind of something, rather than sport, that we are used to. So, I mean, I'm just worried because what it tells me is that these are not our own varieties or cultivars. Thank you.
Okay. The next person, please.
Yes, mine is still on the fertilizer recommendation, where a recommendation of 600 kilograms per hectare was made. So my question now, I hope these recommendations were done with specifying the kind of soil and probably the nutrient status of the soil on which these recommendations are made. Thank you.
Yeah. You want to? Okay, please. Please. Your name, please. Sorry, the last speaker. Your name, please, so that they can.
Professor Godwin Uchenaj.
Okay, thank you.
Godwin Asomora is my name. Coordinator, sweet potato. You were in Nrcri before, and during my tenure here, I brought you back because there was a project we were anchoring on then with a SIP, with a Hugo, a very big project. Yes. I did not hear anything about it again. What is the situation?
Yeah, coordinator, are you ready to shoot?
Sir. Thank you.
Sorry, personally, you mentioned that about 83% in your report decided not to try a particular variety of the
technology.
Yes. Why do you think that they decided not to try? Did you do anything to also encourage them to also try? Or do you consider that particular variety not good at all? Okay? And a couple of people have also mentioned the issue of that fertilizer. It was a worry for me personally. So is there something that you are doing in terms of the communication machinery to educate farmers on what to do?
Okay. Thank you very much. Let me start from the very last one. So actually the technology is on the seed system, not on variety. It's on the seed system, and some of the technologies they can use to preserve their planting materials over the dry season. About 83% did not even try the net tunnel. The triple S system, it is actually a bit technical. And you know our farmers, once something is about being technical, they will just drop it for you. So I think that is just the problem. So that answers that. So for the fertilizer, okay, let me start also quickly address the one Mayoga just mentioned, the project you talked about, sir. That project actually didn't come to fruition. So I had to meet our executive director, and I told him, so when I raised the issue initially, I think it was supposed to be on seed system ProSiva. It was supposed to be on ProSiva, and the report we had was that for West Africa and Central Africa, seed system on sweet potato was not going to be funded. So they dropped it. So myself and my executive director then talked about, so what next? Then he contacted Hugo back, that look, if you guys are not going to do anything on seed, then you guys have to fund some work on breeding. We need help. So based on that, we got funding for some breeding works, which is leading us to releasing the new varieties, I said. And that is why, to connect that straight to Dr. Echendu, that was why you see, because in that project, the materials to be used were actually sent. It's under the Sweet Gain project. So, and that was why we saw. But by the time we will be releasing those materials that we have identified that are good for our environment, they will begin to bear humus for 5, 6, 7. Yes. So thank you very much, sir. On the fertilizer issue in root and tuber crops will continue to remain a burning issue. Should farmers use fertilizer? Yes, they should use fertilizer. Then the next thing is you look for the way to preserve your roots. But it is good, that's why we also give them the package. When you harvest, process. Okay, so they've got to process their roots. Even the fertilizer one, just that we were so much in a hurry. If not, some of them could still get to about 8 weeks after harvesting before they spoiled. And there was differences in the way they reacted to the fertilizer. So if I am a farmer and I know that I don't want to sell immediately, I will plant 87, TIS 87/0087, that even up to up to 8 weeks after harvesting has not even initiated spoilage. So one has to be strategic about what to do. But the fact remains, we will continue to use fertilizer to raise our yield, and farmers will have to sell their roots, and processors will have to process. But even the Mother's Delight will still stay about 6 weeks before it spoils. So it's not as if it's a 2 or 3 day thing before the spoilage comes in. I think that's about the last question, if I'm not mistaken. Thank you very much.
The Prof mentioned something about the connection with the soil, right?
Oh, okay. Yeah, definitely. You see, you have a recommendation for small stakeholder farmers that can do soil analysis. Then you have recommendations for big farms that really want to go maybe into export or into large-scale processing or what have you. So all this recommendation, what we do is the optimum recommendation and most of those recommendations go to smallholder farmers. As a big-time farmer, you have to do soil analysis. If you are going to crop 20 hectares, why won't you spend small money to do soil analysis and then do what you should do to apply the right quantity? But if you are a smallholder farmer that is just doing 0.5 acre or 1 acre, so that's why we make the general recommendation. You can add 400 kg per hectare fertilizer and then you will be fine. But we are saying in a highly depleted soil, that 400 kg is not even enough. A lot of crops are even raising the bar. I think cassava is raising to 600 kg per hectare, and I think we have seen a result that also shows the same trend in sweet potato.
Okay. Let's hear him. I think this will be the last before the coordinator steps down.
Yeah. You see this issue of fertilizer rate is what my colleague has once raised here. You cannot at this era go into agriculture doing it the old way people were doing it and hope to get results. Recommendations are tied to soil fertility class. The rate you apply, if you have a low soil fertility class, the recommendation will be high. If you have a moderate or medium soil fertility class, the recommendations will also come down. If you have a high soil fertility class, you may apply or not apply. If you over-apply, instead of having a synergistic response, you have antagonistic one because of imbalance. So the first thing to do is to ensure that in your trials, you have a soil scientist who will do the preliminary thing, the fundamental basic thing, which most people have been omitting. Cassava, they say, is 400. It's ridiculous. Literature is even a wash. With recommendation that in a low soil fertility class, the recommendation is 600 kilograms per hectare to meet the nutrient requirement of 90 kilogram N per hectare. People are ignoring that, and then they're complaining. So that's just a little thing I want to say there. Thank you very much.
That's
Thank
very
you.
noted, and thank you very much.
Yeah, meet a soil scientist. That's what he has just said.
Actually,
please, at this juncture, let's clap for the coordinator, sweet potato. Please, let's welcome the next program, Opportunity Root Crop Program. Please, the harder you clap, the faster they come. Please remember you have just 15 minutes to do your report and proposal.
Yeah.
Thank you.
Chairman, fellow scientists, may I stand on the existing protocol to welcome you to Opportunity Root Crop Program. It's an Opportunity Root Crop Program because it has so many opportunities you can harness and farmers can harness to improve your well-being. And these crops are underutilized crops that people neglect, but very important for life. And I am Dr. Mrs. Wanyeze Regina Njoko.
Dr. Njoko, is it possible for you to proceed without the slide? I think our slides have been...
What's the problem? How can I proceed? I can't.
This one is not working. Okay, it's connected to this.
Can I have my laptop?
Please, let's be patient. They are trying to sort out, the technical unit is trying to sort out this issue. Dr. Njoko.
Yeah, like I said, these are the opportunity crops. They are turmeric, Hausa potato, Rizga, and Amora. Okay, next. You're welcome to, this is our annual report. The first work we did, we looked at the morphological characteristics of Hausa potato accession for breeding. This is a kind of breeding work. We look to evaluate the root tuber yield performance of the accession, to determine the morphological diversity among the accessions, to determine the duplication within the accessions. This was I thought that showing you Amora. Slide is on the top we have, and the next is morphological characteristics of accessions for breeding. From here, the result, we looked at 16 traits. And from the 16 traits we looked at, 4 out of the 16 traits showed that they have some similarities. That is to say, they are from the same family. And 3 out of the 4 characters, out of the, there is a table. There is a table on yield of these 9 accessions. We looked at 9 accessions. And out of these 9 accessions, 4 gave the highest yield, but ACC4 gave the highest yield with 4.80. Can I have that on the board?
Use your...
Okay. Okay. The results showed that 12 traits out of the 16 are good discriminant traits in characterizing Hausa potato. The 4 related characters showed that If you look at the yield table, you can see ACC 4 that gave the highest yield. The results showed that 12 traits out of the 16 traits are good discriminant traits in characterizing Hausa potato. The 3 related characters show that they are from the same family but different in 13 traits, which indicates they are different and distinct Hausa potato assertions. In conclusion, none of these 9 assertions studied are uniform in all the characters, which showed that there was no duplication among the Hausa potato. Take home here, from the yield data and from the traits we looked at, we are able to come out with that 4 out of these assertions will offer an agronomic background for breeding Hausa potato assertion and therefore recommended. Next. Investigation and development of different post-harvest method of storage in Amora. Amora is a crop we want to bring to the limelight. People don't know much about this Amora. It grows in the wild. So we are trying to see a way we can domesticate Amora or even to go further, carry out breeding work on it. The objective is to determine the best storage method for storing, facilitate early sprouting and reduction of root rot in Amora, because Amora, we discovered we found it difficult to get material, planting material to go into research work in Amora. So because of Amora cannot sprout easily and it decomposes easily. So materials and methods, we store them in the pit with soil. We raise the platform with palm front, store under tree with dry leaves, wood shaving under shade, and sharp sand under shade. From the result, we are able to discover that if you look at the graph, we discovered that the experiment showed that storage in pit under shade with soil covered with soil gave the highest percentage sprout count. The storage with sharp sand gave the highest percentage curing and rot reduction. Take home, storage with sharp sand is recommended for efficient storage, while pit under tree is recommended for early sprouting. Next. The next is production of biofertilizer using different agro waste for sustainable quality of turmeric yield. To investigate the effects of biofertilizer produced from agro waste on turmeric yield, to evaluate the impact of biofertilizer on soil fertility and microbial activities, and to compare the performance of this biofertilizer with conventional NPK 15-15 fertilizer in turmeric. What we did here is that we use organic material like poultry, rice waste, and and we added a microorganism that acted as a catalyst to quicken the reaction. From the result, we discovered that, look, we took the initial soil sample of the soil, and that's the result of the initial soil sample. And after these are the chemical properties of the initial soil sample and the chemical properties of the biofertilizers. And from the result, the biochart result, they are the 16 week, we discovered that biofertilizer 3 gave the highest yield. The effect of treatment on plant height gave the highest yield, plant height at 16 weeks. And the effect of treatment on fresh tuber, what we use is cucumber longa in this experiment. And we discovered that cucumber longa rhizome gave us the highest yield. Biofertilizer 3 also gave us the highest yield. And in conclusion, even compared with control and NPK 15-15, then in conclusion, the study showed that biofertilizer produced from different agro waste could be as an alternative to conventional NPK 15-15 fertilizer for improved soil fertility and turmeric cucumber longa production. It was observed that biofertilizer 3 showed an outstanding performance and therefore recommended for improved turmeric production and sustainable soil fertility. Take home. Take home. Take home on that report. So our take home is that the biofertilizer is eco-friendly, cost-effective, and can sustain soil fertility. The next is exploring the influence of Polynesia arrowroot, which is Amora extract on intestinal motility in rats. Here, the objective is to evaluate the potentials of Polynesia arrowroot, Amora, on intestinal motility. What are we talking about here? We are saying that we are trying to evaluate on rat. The intestinal motility refers to it is the contraction. What do we mean by the contraction and movements of muscles in the movements of intestinal muscles? When it is proper motility, proper nutrients absorption and waste elimination. When it is faster, motility results in diarrhea, and when it is slowed, motility results in constipation. From the result, we had about 6 treatments here. The methodology, we had control. We had another control check, that is Lopemed, that is the normal drug. This is more pharmaceutical. The normal drug at 0.5, and then group 3, we looked at 4 milligram per kilogram body weight, 400 milligram per body weight, and day 2, which is 800 milligram per body weight, and for 5, which is 400 and 800 milligram per body weight. What do I mean here? The 400 and 800 body number, day 1, day 2, that was dried, processed, and this milligram was taken, added water, and fed the rat. The other one was soaked overnight. The 2 was soaked overnight, dried, and then milled, and we did the same thing and fed the rat. From the result, we discovered that if you look at the badge at the number 1 there showed 61.01.
Dr. Njoko.
That is control.
Dr. Njoko, as you are aware, we are racing against time, so I want to encourage you to...
I missed some time, sir.
Yes,
yeah.
Please.
So what we are trying to say is that Amora can actually, Amora has potential to slow down intestinal motility, and it should be evaluated for further anti-diarrhea activities. That is our take-home. Next. As assessment of indigenous knowledge of Hausa potato among rural households. This is an extension work. The objective to document indigenous knowledge of reference community on cultivation and storage, processing and utilization. To document the challenges and constraints encountered by farmers. We looked at, that is the methodology we looked at, cultivation method, cultivar, they have about 2 cultivars, type of seed planted, type of fertilizer, organic fertilizer, the planting, period of planting in May, and time of twice, storage, sack, processing method, drying. Results show that the major concern were lack of funds, limited access to inputs, and reliance on rudimentary storage technique. Conclusion, we concluded here that the findings reveal that traditional farming methods dominate production of Hausa potato, with region, brown cultivar, split seed, organic fertilizer being widely adopted. Recommendation, we are recommending that to enhance Hausa potato production and utilization, efforts should be focused on improving access to inputs, extension services, and post-harvest management strategies and value addition. Women and youth cooperatives, awareness, attitude, and participation towards turmeric production in southeastern Nigeria. To assess the level of awareness of turmeric production technology to ascertain the farmer's attitude towards turmeric production. The methodology we used, we looked at time of planting, effect yield, mulching effect yield.
Dr. Njoko, please conclude.
In conclusion, the respondent has a positive attitude towards turmeric production. It is therefore recommended that regular visits should be organized to provide technical guidance on turmeric farming. Thank you.
Let's give her a round of applause.
Proposal.
Okay, just use 3 minutes to summarize all your proposal, please.
Yeah, we want to, no breeding work has been done in turmeric production, and no turmeric variety has been released. So we are targeting to release turmeric production from opportunity root crops. And by so doing, we are trying to do more of breeding work in turmeric. We are starting by induction of genetic variability in turmeric for variable flowering using cuticin, indoors, multigenesis, and in vitro culture techniques. The objective is to induce genetic variability in 3 selected turmeric genotypes using cuticin. Standard operating procedure for hybridization in turmeric for successful controlled pollination. Continue. Effect of different rates of agrolyzer on turmeric production and its impact on soil carbon sequestration for improved land management. Evaluating the anti-diarrhea and the anti-homology activities of Polynesia arrow roots. Assessment of youth and women investment in turmeric value chain activities among smallholders farmers in southeastern Nigeria. Assessment of indigenous knowledge and practice in the production and utilization of African yam bean in Abia, Cross River states of Nigeria. Thank you.
Thank you very much. Please, anybody that has suggestions, questions, and advice for this group should indicate. I have one person. Any other person? All right. There's somebody at the back.
Thank you. I think mine is just maybe an input that, like, there's one of the trial of last year where they want to, they used morphological assessment to conclude on the genetic diversity of those materials. And I want to suggest that that may not be sufficient to make such conclusion until you do some genomic work before you conclude that having phenotypic parameters that shows that they are distinct does not actually speak to real diversity nature of their sections. Thank you.
Thank you. Dr. Njoku, did you hear what he said?
Noted, sir.
Okay. So there are a lot of, okay. Madam has, all right. Continue with, Madam, you be the last, please. Thank you.
Thank you, Mr. Chairman. I am worried with the title of your first presentation.
Your name, please.
I am Dr. Edi Mogu, retired but not tired. I am worried with the title of your first presentation. You captioned it, Production of Biofertilizer Using Different Agro-Waste for Sustainable Quality Turmeric Production. But in your objective, you indicated what you set out to do, none of which actually centered on production of the fertilizer, but you were rather monitoring the impact of the fertilizer. So I would suggest you look at that title critically once again, because the title does not convey information in respect of what you set yourselves out to achieve. Secondly, the fact that this program is called Opportunity Program, I don't know what you call it, Opportunity Crop.
Opportunity Root Crops Program.
That means that all the other crops we have been talking about this since yesterday, they don't have opportunity. Does it mean so? I would suggest, to avoid that bias and misconception, look at the title of that program again, the name given to it, and find out an appropriate name that will befit it instead of calling it Opportunity Root Crops Program, because it underscores the opportunities that exist in the other root crops unit. Thank you very much.
Thank you.
As a one-time coordinator of the program, now I didn't see any proposal in RISGA. RISGA, no proposal. And when you were mentioning your crops in the program, you never mentioned the sugar beet. Don't you know it's one of your crops there to research upon? So I was happy when I saw American yam bean. We have African yam bean too. You can include it. Expand your crops. You have so many crops there. So make sure you look for them and research on them. Thank you.
Thank you. Noted.
Yeah.
Or do you have any, you want to respond to?
Yes.
Okay.
You said we didn't look at the production of biofertilizer, but we gave the yield data of biofertilizer. Then we can, from there you can go into production, using it to go into production, Dr. D. Then the title of the program, that is management issue. Then my madam, RISGA, we have work on RISGA ongoing. We didn't present it. And sugar beet is not all opportunity root crops that we'll carry at a time. We know it's part of one of our programs, but with time we'll go into that. Thank you.
Thank you very much. Let's clap for her some more, as we also invite the production unit for their presentation. The production unit. If the production unit is not ready, may I invite the farming system research program for their. Is it the production unit? Okay. Are they ready? Please, coordinator farming system. Please, hello everybody. We are going to tweak this program a little bit now. So we are going to give them 10 minutes, the farming system step, and that of extension service. As soon as, hello, are you listening to me, sir? As soon as you are done with your presentation, you come and sit down. Just 10 minutes. The next person will come and present. Yes, then we can take questions from the floor.
Okay,
are we okay?
Yeah,
all right.
Good afternoon, Mr. Chairman.
10 minutes, please.
Orders. So let me just go ahead to my presentation. So this is farming systems. First of all, our achievement. So we're, for 2024, under training, we're able to transfer improved technologies to farmers through monthly training review meetings of the ADPs. So we train them on cassava value chains, broiler production,
soil management, oil palm production, good agronomic practices for cassava production. We as well train 115 extension agents, women and youth farmers in ecological agricultural practices. We did this in collaboration with National Program for Food Security. We also train our workers with our field workers, and those of them from College of Crop and Soil Sciences, Michael Opera University of Agriculture, on field data collection. So we're able to make the following findings within the year under review, based on our different units. Under climatic smart agricultural practices, we were back. Under climatic agricultural practices, we were able to find, for you to optimize your yield and again environmental stability, you have to apply 1.8 tons of cow dung plus 45 kilograms of nitrogen under split application, plus 5 kg P2O5, plus 45.38 kg muriate of potash under split application for cassava production. And at the same time, we're able to find that for the last 2 decades, the trees in Nrcri have been destroyed, exposing the community to high surface runoff and erosion. We're able to also find out that the land use in Umudikena has increased from 12 to 13. Also, we're able to find out that the water quality of our reservoir is powerful, is excellent for agricultural practices under irrigation and for aquaculture production. Under livestock production, we're able to find out that 10 grams of turmeric liquid decoction is an alternative to synthetic antibiotic for broiler production. At the same time, we're able to find out that 15% inclusion of yam peels and unsellable yam tuber meals is excellent for broiler production. Under fisheries, we'll be able to find out the water quality of Umudike 18 pond is better than that of Makode, while the soil of Makode is more suitable for aquaculture compared to Umudike soils. Under adoption studies, we are able to find out that there is moderate adoption of our improved cassava varieties, that's the yellow type, in the northern part of the country. So our report, first of all, this is the monthly technology review meeting. Our target was 12 per state, but look at percentage achievement. It's only Abia that has 67.67%, followed by Enugu that had 8.3%. Anambra, Ebonyi, Imo, they scored 0%. Then when you come to other activities like the refields workshop, diagnostic soil survey, zonal technical committee meeting, joint scientific, we scored what? 0% in the whole southeast zone. The next, let's move, the next slide. So the next one, we are trying to look at the, we are trying to enhance cassava production through climate smart agricultural practices. So here what we are trying to do is to, if you look at the guest speaker's speech yesterday, which time are you supposed to apply fertilizer, at what rate, so that the plant can make very good use of it, so that it will not cause environmental problem. So look at the table. First of all, what we do, we have to establish the nutrient requirement for cassava production. We did our soil analysis. We now did the analysis for the cow dung that we put. Please back. So at the end of the day, the cow dung, we applied it a month before planting. Then the nitrogen, we applied 4 weeks after planting. That's 50% of it. Then the phosphorus, we applied everything immediately after planting. While the muriate of potash, we applied 50% of it immediately after planting. The remaining 50% of the muriate of potash and urea, we applied 8 weeks after planting. At the end of the day, we were able to find out that treatment 3, that's 1.8 tons of cow dung, plus 45 kg nitrogen, plus 6 kg P2O5, plus 43.57 muriate of potash, we are able to give us better production, and we recommended it. Because of the problem we have with straight fertilizers is availability. You can get your urea, sometimes you can get your triple phosphate, but the problem is muriate of potash. So therefore, if you cannot get that, please, the conclusion for the other one. So this is equivalent, so this one is equivalent to 1.8 8 tons of cow dung, plus 300 kg NPK, 15-15, or 250 kg NPK, 20-10-10, or 275 NPK, plus M2, 12-12-17 plus 2, or 166.6 NPK, 27-13-13. For information, NPK is not NPK. They have different classes and they have different recommendations. So here we now try to look at evaluation of biological weed control efficiency and productivity of varied cover crops in ginger maize intercropping system. National Root Crop Research Institute, we now recommend to farmers, if you want to grow your cassava maize, you use mulch of 20 tons of wilted panicum maximum. Where can you get that if you are in Savannah area? And at the same time, in farming system, we're able to find out that ginger maize and these various cover crops, they are compatible, but there is a gap. We now try to look at the rate of weed control. At the end of the day, we're able to find out that mulch is an alternative. So lesson learned here is that among all the biological weed control of varied cover crops used to control weed, mung bean showed good weed control alternatives. If you look at the table there, you can see it. So we now look at the agricultural reservoir operation strategy of National Root Crop Research Institute, Reservoir Umudike, considering climate changes. In this experiment, we will use what we call the longitudinal research design, whereby we make use of the soil, the weather, and the water reservoir, and the satellite images. At the end of the day, move. So we're able to find out, you can now see this, even including the digital elevation model. At the end of the day, we saw that in the last 2 decades, the trees in Nrcri have destroyed, exposing the community to high surface runoff. And at the same time, we're able to find out that the water quality from the reservoir is good for crop production under irrigation and a good source for aquaculture production. The next slide. So here, we are now trying to enhancing growth performance of African giant snail, that's Acacatina marginata, fed with cocoyam and feed potato peels. So we are now trying to look at, can we have alternative to conventional feed or concentrate that we can use in snail production? So we have our conventional, that's the feed mash. Now we have the cocoa with the cocoyam peels, and we have the sweet potato peels. At the end of the day, we're able to find out when you look at the result. So look at the T3, which is the cocoyam. Look at the weight, the dressing weight, was able to give us 33.7, which is better than the conventional T1 that gave us 32.9. At the end of the day, we concluded that you can use sweet potato peels and leaves and cocoyam peels and leaves for your snail production in comparison to conventional or commercial feed. Next slide.
Please stand.
That's our take home. Then here, we growth response of broiler chicks, fed diets containing yam peels and unsellable yam tubers. You saw yesterday during the discussion, Dr. Okereke mentioned of this. Next slide.
Coordinator.
So what we
don't have all the...
So what we try to do here...
Please, 1 minute more. 1 more minute.
Okay, 1 more minute.
Yes.
So what we try to do, let's go back to Okereke. You can look at the creatinine, the hemological and serum chemistry parameter of broiler chicks fed with this diet. Look at that creatinine. Look at the 15% inclusion of yam peel. It has no negative effect on it. It's within the permissible level. It gave us 0.48. So from this finding, apart from the body weight, so we're able to find out that 15% inclusion of yam tuber meals and unsoluble yam tuber can be included for broiler production.
Let's
Next
clap
slide.
for coordinator, please. Coordinator, thank you very much, please. please come and sit down with me while we invite the coordinator in charge of Extension Services Program. Please, if you have any question for him, write it down. At the appropriate time, you'll be called upon to ask. Please, the... We don't have... Proposer. All right, oh yeah, quickly, 2 minutes, please. Summarize your proposal.
Okay, let's go to. So the first proposal here is monthly technology training meeting. The target is 12. Other activities, like we have our refill workshop, we have scientific meeting, we have technical training meeting. So that one, again, we've proposed. So next slide. So this is productivity and biological weed control, efficiency of varied cover crops in cassava maize intercropping system. Next slide. So this is on-farm trial, evaluation of compatibility and productivity of cassava and upland rice in an intercropping system. Next slide. So estimation of soil loss by reversal United Soil Loss Equation model using those spatial techniques, a case study of National Root Crop Research Institute, Umudike. Next slide. Exploring the therapeutic effect of ginger and garlic supplementation in broiler diets, alleviating heat stress and enhancing performance. Effect of climate change on beekeeping production in Akwa Ibom State, South Nigeria. Next slide. Next slide. So climate change and flooding menace along yam and cassava farmers in Anambra State, Nigeria, adoption for sustainable agricultural yield and relevance in global food.
Thank you.
Next slide. Carbon sequestration potential of cassava PGMP intercropping systems. Next slide. Evaluation of the role of extension services empowering youth and women yam farmers, cooperative in neighboring state. Next slide. Comparative effect of feeding composite cassava and sweet potato meals to broiler chicken, TMS 419 and mothers delight. Next slide. Electrolyte and epidemiological profile of growing Acacatina marginata fed with cocoyam and sweet potato peels and leaves. Next slide. Evaluation of women and youth farmers, priorities and adoption of some recommended cassava production technologies through extension services in neighboring state. Next slide. Intercropping effect of Polynesina arrowroot and maize in Umudike agro rainforest zone of Nigeria. Next slide.
Please,
Next slide.
I'm sure we've seen all your proposals, so we don't have all the whole time. Please, let's clap for him some more. May we at this juncture invite the coordinator in charge of Extension Service for their presentation. Please, if you have any question, just write it down. You'll be invited to.
Yeah.
Dr. Koye?
Yeah, thank you.
You have 10
It's okay.
minutes to do everything.
It's okay.
All right.
Distinguished moderator, all protocol duly observed. Yeah, welcome to Extension Services Research Program. We offer services. We do research. We do media. We print and bind, and women in agriculture inclusive. Next slide. Annual reports. The first is dissemination and promotion of Nrcri RTB crop technologies through demonstration farm. We have a demonstration farm where we receive students, where we receive farmers, NGOs, private sector, and major stakeholders to showcase what we are doing here. The plants. The achievements include that we established the farm, several RTBs planted, students on excursion visited demonstration farm. This is how we have fared in terms of excursion, with a total of about 5 tertiary institutions, 4 secondary, 2 primary that came. Then capacity building workshop for youth and women cooperative entrepreneurship development using RTC's technologies. When I mention RTCs, root and tuber crops. So partnership for entrepreneurial development training workshop was held among cooperatives in Abia State. Activities had to do with, we carried out training, then overview of root and tuber crop technologies, and then most of these materials disseminated. Capacity building workshop for young scientists on grant and proposal writing. We also try to carry our young scientists along to intimate them and integrate them into the system of what they stand to face in future. We trained young scientists on proposal writing, methodology, and the work plan and budget, on how to source for grants. Then transfer of Nrcri technology through adopted village school outreach. We still do this, trying to adopt schools in terms of dissemination, rapid dissemination of our technologies. The objectives were to disseminate technologies. The target was women and youth. We established demonstration farms and encouraged the youths. The location was Olokoro Community, Isieke, Methodist Seminary in Ndoro, and Oboro Secondary School. We paid advocacy visits before we commenced. These are what happened within the schools we went to adopt. Training of students on root and tuber crops, and the students actually doing hands-on training on the technologies. These are crops that were planted in their farms, or the students planted in their farms, and this is the harvest. The popularization of turmeric production and processing in Imo State. This was also carried out in terms of turmeric, which is actually becoming an export crop in Nigeria. Training was held, and farmers actively participated. These are the activities during the turmeric training, production, and it also included processing. Farmers perceived impact of taro leaf blight, another project on rural livelihoods. Taro leaf blight has continued to affect productivity of cocoyam. So we want to see or perceive what the farmers are saying. And then the lessons learned were that men highlight hair draws, women were noted leaf decay signs, and they also told us that actually it has to do with weather, which is in order. We also did extension guides, about 7 of them, at various stages of production. Study on effectiveness and cost-benefit analysis of different disease control measures. This also was carried out in Kaduna State. We had assessment of the effectiveness of extension services to the needs and challenges of youth and women cooperatives in Anambra State. Objectives were to evaluate gender responsiveness, identify gender-specific challenges in that order. And some of the lessons learned were combining group training, farm visit and demonstrations, impact on empowerment, and then there were major constraints, which we also found out. The media outreach training, digital engagement, and documentation by the media unit. The media unit is in charge of the image making of this institution, telling the world what we do. You can see some advocacy visits paid by the institute or that happened within the institute and outside the institute. They included the annual review meeting, workshop on RTB breeding, IITA tri-court workshop participant for 1,000 farms, then IITA AATF collaboration, where we trained more than 6,000 Nigerian cassava farmers and processors in the West. Another one is establishment of the regenerative agroforestry farm, Nrcri Qatar's collaboration, the Chinese partnered with them, then where our ED was honored by the Plant Breeders Association. Even the security chief, they're also interested in agriculture. You can see the woman there, Director of State Security Service, coming to see what we do in the institute. Sahel also, strategic partnership with Sahel, which was presented earlier. Chinedu Abara talked about it. Then Nrcri and Futo holds executive track A and B workshop. GBPP partners with Nrcri. Then roundtable meeting with GPP stakeholders. Most of these strategic meetings are all to enhance innovative technologies for food security in this country. Stakeholder meeting on taro. We're also trying to combat taro problem. That is cocoyam blight. Then what the media also covered the release of 2 improved varieties of cassava.
Dr. Koye, you have 4 more minutes.
Good. Training of Olokro women groups on root and tuber cross production using biocar, which also happened within the year under review. Dr. Mr. Ibunama and her team trained Olokro women on use of organic fertilizer. The impact of adoption of improved cassava and sweet potato technologies on the livelihood of women farmers in Anambra State also happened. Studies found that high adoption of cassava improved technologies while sweet potato was low. So the idea is that we have to also do so much on sweet potato in terms of technologies that we generated that are still on the shelf. Evaluation of key determinants of youth engagement in agribusiness and food security and nutrition. This also happened. Extension services program of work. Do I continue?
Yes.
It was less than 10 minutes, sir.
Yes, you have about 3 more minutes.
Annual report is over. 10 more minutes for this one. Okay. Okay. Essential services program of work. The media and publicity unit will continue with their image making of the institute and our services, dissemination of our technologies, etc. Popularization of Nrcri root and tuber crop technology through demonstration farm. We'll continue with that. These are routine activities where students will come for excursion and other stakeholders and they see what we do in the institute. Training of Umudike women groups on root and tuber crop production. We continue with Dr. Mr. Ibuna leading. Assessing the impact of adoption of improved root and tuber crop technologies on the livelihood of women farmers in Abia State. We have generated a lot of improved varieties. We want to look at how far we have fared in adoption and dissemination. Transfer of Nrcri technology through Adopted Village program. The intent now is adoption. Even it's in the policy of the government of the day. Study on the utilization of Nrcri improved crop production equally among farmers in the host communities. We want to also see how we can rapidly popularize some of these innovations, even in the host communities around us. Assessing the effect of different essential media methods on root and tuber crop technology, utilization and adoption in Southeast Nigeria. Vulnerability of taro. We are still trying to do more on taro, and what are the farmers doing? How can we improve on what they are doing? Assessing the effectiveness of agricultural extension on the management of and control of taro blight. Yield performance, water use efficiency, and sustainability of irrigation systems. Implications for enhanced dry season ginger production and turmeric. Factors influencing farmers' awareness and adoption of climate-smart practices. Implications for sustainability and crop resilience. Climate-smart technologies for root and tuber crops. The role of extension service in Southeast Nigeria.
Please, let's clap for Dr. Koye. Dr. Koye.
Thank you very much.
Thank you very much.
Yes, we're almost done.
Thank you very much. May I also invite you to come and sit down with me here while we receive suggestions, questions. No, just come and bring, please. Doc, bring your mic, please. Please, questions, observations, suggestions. Yes, I have seen 2 hands up. Yes, go ahead, sir.
Thank you, Mr. Chairman.
Please indicate if the question is for the coordinator in charge of farming system or extension.
Farming systems.
Okay.
I'm happy to know that MTRM is coming back. You targeted 12 MTRMs per state. Only very few, 1 or 2, had certain percentages. The others that scored 0%, did you go to find out why? That is one. Some time ago, we suggested here also, for extension purposes, that the institute should establish an outstation, outpost in town, where we can display a number of our products. I'm not sure that was taken or anything has happened about that. An outpost in town. Chairman, are we together?
Yes, we are.
Okay, we have suggested an outpost in town where our bulletins, our productions could be displayed for people to see. I didn't hear anything about that, whether it was cancelled or not. Thank you very much.
Thank you.
Thank you, Mr. Chairman. My question goes to Dr. Okoye.
Dr. Okoye?
Okoye.
Okay.
I'm happy to see the adopted village again. Last year, we didn't see it. What is the update? Because it's a very veritable instrument in pushing the research findings. Second question is, are there suggestions or recommendations to policymakers in the way of the young men we have nowadays are not interested in working. They're interested in money. They're interested in money. And there's need to suggest something that will motivate them or make them come in. Let me give an example. In 1963, opera started, if you enter College of Agriculture, we shall pay you. Some of us who didn't want to study agriculture, we went into agriculture. They also started at the end of the war. People don't want to teach. But if you want to take education, you got scholarship. So these are ways we can suggest tangible things that can attract them. All these jamboree workshops, I have seen the ones you are organizing. People that attend, each time I see anybody with all this, man with a coil hair, it's not for agriculture. These are Yahoo people. They just come and collect allowance and go. So you should do something positive to attract people into agriculture. Thank you very much.
Thank you. There's somebody at your back, sir. Yeah.
Yes, I was looking at the organic manure rates you use, the farming system. I'm referring to the farming system person. And I think it's very, very low. None is up to 5 tons per hectare. So I was wondering what informed the use of such a low level of organic manure you used for the experiment. Yes, it was less than 5 tons per hectare. I mean, not fertilizer. So I don't know, if you go through literature, you may find out that very higher recommendations is given for such, for those places worked on.
Okay, Dr. Simonia. Okay, after. Okay.
You see, man is on the other side. He said the organic manure rate is very low. But looking at what Nwokom presented, 1.8 tons per hectare. My question is, how feasible is that?
Thank you, sir.
Okay, mine is to Dr. Okoye. In extension, after dissemination, we talk about adoption. And from there, we assess impact. I'm coming to the adopted village. We started this work on adopted village as far back as 2012. When Dr. Lago was the first coordinator, and he started it both in Amawo and every other place. And after that, we took over. We had some schools, both in Imo, Abia, Anambra, even in the FCT, when Dr. Nunka was there. You know, Have you tried to ascertain those technologies disseminated there? What is the status? Are they still doing it? Or is it after you pulled out, they abandon everything? What is the sustainability? Nowadays, we talked about sustainability. Whatever technology you are trying to disseminate now, there must be a way to sustain it. Those ones we started first, before you started adding these ones. What is going on? What is the level? Thank you.
Thank you. Any other person? Okay, let's invite the coordinators to answer. Okay.
This is a follow-up to what you have just said now. I'm thinking that if your research institute cultivates the habit or idea of making use of, say, companies, you'll be more conservative in making sure that your research work is conserved. Because the C companies are private entities that are interested in profit making. And any technology they get or they have to acquire that can enable them maximize profit, they will never let it go. Please, I'm trying to request that each time you have any of this research output you want to make available to the public, consider also the same companies. Thank you.
Thank you very much.
Yeah, thank you. Thank you very much. Let me start from the questions. The question raised by Dr. Muzo. Yeah, actually, it's not easy for us, for the MTRM, refills and others. That of Abia State that made that impact is under the sponsorship of Life ND, not under the sponsorship of state government. And if I tell you that for refills, the effort we've made is not yielding any positive result. But that of Southwest, they had their own in February. I don't know what is wrong with Southeast. I wrote to Commissioner of Agric in State, thank God the PM of Ebo in ADP is here. I wrote to the Commissioner of Agric. She told me she doesn't work with WhatsApp. I asked them, it was downloaded, they sent to her office, there was no reply. I had an appointment with her, she said she would come. That day of going there, she told me they should tell me she won't be around. So I ended up meeting with the man who is in charge of IFAD. He told me he released little money for MTRM. But I was informed that they use it to attend a meeting in Zaria, that's the extension meeting in Zaria, which is also important. So the other day, I called the program manager, meet the commissioner again. She made the commissioner to book appointments. She said, until I call her. And I call her, she's not picking my call. That of Enugu, I even wrote to him pertaining to the refills. No response. But Enugu is making impact now. Even the last MTRM I attended there, the former commissioner was there. That's Professor Martins Nrcri, Buffalo. He was there. The PA was there. The present commissioner was there. So they are making impact for MTRM now. But the problem is refills. Like the C companies here, if Chief Wanevo can sponsor us or you can get sponsorship for us for refills, we will like it, sir. You have the connection. So if I will come, then we discuss with you. Then in line with what you said, sir, we have a system. We will develop our technology. We pass it to ADP through the MTRM. Then we pass it to the extension officers at FNT. Those ones, when they visit their farm families in the circle using the T&V system. So that's why if the seed company want to be part of it, they can now sponsor the MTRM so that they can now be part of the MTRM. They can now get the technology from ADP system and now descend to farmers. That's on that, sir. So for Professor Naji, You said that 3 tons, that 3.6 tons is on the low side. You know about crop nutrition. So you can't put anything you see in the soil. First of all, what crop are you growing? Then you establish the nutrient requirement. After that, the next step is what is in the soil. You carry out your soil analysis based on what is there. Then the next step, you ask yourself, what input am I going to put to make up for the requirement? Like what we did our soil analysis. We now saw that the nitrogen is of low fertility class. The potassium is of low fertility class. The phosphorus is of high class. The phosphorus was standard. So, and if it is of high standard, you know it needed only 5 P2O5. So, in that aspect, so we now did our analysis for the cow dung. And that cow dung, after the analysis, so we were able to get the result. Then that was how we saw that soil, for it to produce cassava optimally, it needs 3.6 tons of cow dung. So let me come to Professor Chinaka. You say how feasible is that? We are even talking of 3.6. We got our material from Michael Opera here, their livestock unit. Because the initial arrangement and objective of that work is what can we get? It's a sort of integration, livestock crop integration farming systems. But the animal science department of Michael Opera disappointed us because they are supposed to bring their own report from what they did, because they collected the crop, the maize, which they used to ensilage the maize, ensilage the cassava leaves, the sweet potato leaves, and fed to their livestock. So we want a system whereby the issue of feathers, farmers clashes. Let's see if we can develop a technology whereby we can now make use of the cow dungs to fertilize our soil, to increase the soil health and fertility. Then on their own, they can take whatever thing we are getting from the crops and feed their animals. But it's not complete. But let's see next year if they can give us the data. They are supposed to bring the data so that we can now present. It is feasible, sir. Even if you go to Abatu around that Umunochi, the only thing is it depends on locality. So if you are not within those places like Ebonyi State, you advise them to use rice meal husk, go and analyze. So it depends on the availability and the area you are, sir. I think I am done with the reactions here.
Yeah, thank you very much. So let me also do justice to these ones. In terms of test marketing, that is from Dr. Muzo. If we have a test market center in town, yeah, we are trying to do something like that. If you go to town, and even in Umudike environs here, you see some of our products from the food science, the OFSP bread. They showcase some of them in town right now. And from there, we have feedback on what the consumers are also saying. Then update on adopted village. Yes, we are trying to do our best. Everything has to do with funding. The funding is also not coming again for this adopted village since WAP left. But we are trying to sustain it. The management is trying to sustain it on our own. At least we were able to pull this through with 3 schools last year. Can you give us a hand of applause? Then suggestions on policy. Suggestions on policy. Our young men are not interested in agriculture. Yes, we are trying to do a lot because we, in extension, ours is to disseminate and popularize. But what I know is that the breeders, most especially, they are also doing a lot to see how we can reduce drudgery. Because one thing is about drudgery in agriculture. That's one thing that scares some of these youths away. So drudgery, we are trying to do a lot of, trying to innovate in terms of varieties, and even some variety that we even yield early yielding in terms of that. So it's all about just drudgery to make them come and make quick gains in agriculture. Then Dr. Smowa, my former acting ED, you talked about impact. Yes, I didn't finish the presentation. There are impact studies already. I would have showcased them as a proposal, especially at Ibariam, the AROC there. Somebody is also trying to do impact study there, in the schools and the environment and the communities that adopted village happened. It's a good one so that we'll know if it's sustainable, and if they have issues, we should know and pick up from there. Then seed companies partnering with Nrcri. Dr. Onyeka, can you say something? Seed companies, huh? Okay. Because I know the Umudike seed company is partnering with some seed companies already. So we are trying, unless we need to also intensify efforts. The question was from Nwabudo Farms. Because I know we are partnering with Nwabudo. We are partnering with Nwabudo Farms. Early generation seeds and the like. So I think that is all, sir.
Okay, a round of applause for the coordinator, Extension Service and Farming System Research Program. Dr. Tessie? Dr. Tessie, yes, you can step down. Are we inviting the production unit? Okay, so in the absence of any further presentation, may I, on behalf of our director, Dr. Phillips, thank management of National Root Crop Research Institute for the invitation and wish.
Please, a round of applause to Dr. Obunaya Ote from the Agribusiness Department of Michael Okpara University of Agriculture, Mudike. We want to thank you so much. Yes, that was a wonderful sharing. And we also want to thank the rapporteurs. So at this point in time, we want to declare that we have gradually come to the end of this presentation, the technical session, and I'll be handing over to the director, PME, who will now invite the executive director for other necessary things that we'll need to do. Director, PME, I would like us to celebrate ourselves. We have done so well. Oh. Can we clap for ourselves?
Hip, hip, hip. Hip, hip, hip. Yeah, I'm so delighted that we have done 2025 external in-house review. I will now call on my executive director, who is ably represented by Dr. Olojode. Olojode, sir.
I think we can give ourselves another round of applause. Actually, in the real sense of it, it's not been easy. Tying people down. 24 hours in 2 days. But I want to thank you now. All hands were that started well. And I think we need to give ourselves kudos for that. But you will just, before I present the closing remarks by the ED, there's one thing that we need to quickly do. And I think within 5-10 minutes, they should be able to do that. Then I will give the closing remarks for the ED, and we declare the meeting formally closed. So I will call out, you know, whenever you have an outing of this nature, there should be what we call communique. So I'm going to call the chairman or the communique drafting committee, but if it's not here, because it said you ought to have an online meeting. So I think Dr. Okoye can actually stand in for him. So I call the following people out as members of the Communique Drafting Committee. I have Dr. Amadi as the chairman. Dr. Okoye, can you please come? Dr. Afape, Dr. Marcel, and Dr. Damian Njoku. Please, if you hear your name, let's make it very fast and brief. Thank you. Dr. Koye, can you?
Sorry, I will read from here, please. So, communique of the National Root Crop Research Institute, Umudike Annual Review and Planning Workshop held between 9th to 10th April 2024 at the Library Complex. Preamble. The National Root Crop Research Institute, Umudike Annual Review and Planning Workshop took place from the 9th to 10th April 2024. At the Institute's Library Conference Hall. The theme of this workshop was a sustainable future for Nigeria's agriculture, focused on root and tuber crops. The workshop brought together a diverse group of stakeholders, including policymakers, scientists, academia, former executive directors and directors of Nrcri, provosts, federal colleges, deans of faculties, of universities, farmers, NGOs, His Royal Highnesses of host communities, and representatives from the private sector. The workshop was officially opened by the Honorable Minister of Agriculture and Food Security, represented by Dr. Aloysius Umba, Head of Station, Federal Minister of Agriculture and Food Security, Umudike. The welcome address was delivered by the Executive Director of Nrcri, Umudike, represented by Dr. A.O. Olojede. Goodwill messages were conveyed by the Executive Governor of Abia State, represented by the Honorable Commissioner of Agriculture, Dr. Cliff Agbeze. Others include provost paper presentations. The keynote address titled, "Is there a role for materials in sustainable root and tuber crop production?" was delivered by Dr. Chris Odimba, Head and Chief Scientist, Department of Analytical Chemistry, the Connecticut Agricultural Experiment Station. The paper titled, "Not to Waste Not by Building High-Quality Cassava Peels, Mash Factories and Small-Scale Levels," was delivered by Dr. Ihanacho Okike, the leading paper presenter. The event also featured panel discussions and presentation of annual reports and program of work from scientists from various commodity and service programs of the Institute. The keynote address highlighted that the integration of advanced materials and nanotechnology has promising potential to transform root and tuber crop production sustainably, ultimately contributing to food security and insecurity arising from increasing food demand. Agricultural production must increase by 70 to 100% by 2050 due to growing population. Current agricultural practices that rely heavily on agrochemicals lead to pollution and decreased efficiency, highlighting the need for more sustainable methods. Both natural and synthetic materials are essential for enhancing agricultural productivity and ensuring food safety. The application of nanotechnology improves the effectiveness of agricultural materials while minimizing their environmental footprint, including the development of nano-agrochemicals for better pest and disease management. Partnership between universities, research institutions, industries are crucial for harnessing natural resources and developing sustainable agricultural solutions, aligning with national sustainability initiatives. High-quality cassava peel for livestock feed innovation provides a sustainable solution to Nigeria's growing feed scarcity by utilizing underutilized cassava peels as an alternative livestock feed, enhancing the productivity and availability of animal source foods while minimizing environmental waste. This initiative has the potential to generate approximately 200,000 jobs, particularly focusing on empowering women in the cassava processing value chain, which promotes gender equity and inclusive economic growth. Recommendations. The workshop arrived at the following recommendations. 1, promote sustainable agricultural practices by encouraging the adoption of integrated pest management, organic farming, and agroecological approaches to minimize reliance on agrochemicals and enhance food safety. Support the high-quality cassava peel innovation for livestock feed by providing financial and technical assistance to scale the HQCP MASH initiative, ensuring that it effectively addresses feed scarcity and promotes economic opportunities, particularly for women. Encourage partnerships among academic institutions, research organizations, and agricultural industry to leverage expertise and resources. Collaboration should aim at exploring sustainable agricultural solutions, such as biopesticides derived from root and tuber crops, and aligning efforts with national agricultural sustainability initiatives like the Green Imperative Project. Focus on utilizing materials such as nanocellulose from agricultural waste to minimize nitrogen and phosphorus leaching. This approach can improve nutrient retention in soils, thereby promoting more efficient fertilizer use and reducing environmental pollution. Implement training programs for farmers and processors to educate them about the benefits and methods of utilizing cassava peels for livestock feed while promoting best practices in processing and marketing. Launch awareness campaigns to promote high-quality cassava peel mash and other sustainable feed initiatives while developing market pathways to connect producers with potential buyers in the livestock feed industry. Conclusion. The annual review and planning workshop of the National Root Crop Research Institute, Omodike, emphasized the need for sustainable agricultural practices focusing on root and tuber crops to address food security challenges in this country. With a growing population demanding increased food production, the integration of advanced materials, particularly through nanotechnology, offers innovative solutions to enhance agricultural productivity while mitigating environmental impacts. The workshop highlighted the transformative potential of high-quality cassava peel as a sustainable livestock feed alternative, which also promotes economic opportunities and gender equity within the agricultural sector. Stakeholders were encouraged to foster collaborative partnerships, adopt sustainable agricultural methods, and support initiatives that enhance both productivity and environmental health. Collective action through these recommendations will be crucial in ensuring a sustainable future for Nigerian agriculture, ultimately contributing to national and global food security. Signed, Professor Chidozie Egesi, Executive Director, Nrcri Modike. Thank you very much.
Yeah, I think they deserved a better applause, much more than that. I think they are quite succinct in delivery and capture virtually everything that transpired here. So Dr. Okoye and your team want to say thank you a lot for the efforts. So shall we just clap for them once again as they take their seat? Without wasting much of our time, I will invite all the senior directors to the high table, starting from Dr. Amadi, all the
technical directors, please can you join me at the high table? Please, let's do it very fast. We're all into it together, so, okay. Yeah, I've been looking towards this moment in which I've been praying that let this cup pass over me, but not my will, but God's will. So I'm standing once again to represent our Executive Director and the CEO of the National Rural Research Institute, Mudeke, to present his closing remark after 2 days of very serious and hard work. By the special grace of God, I will stand on his behalf and read the closing remark. So on behalf of the Executive Directors to CEO, Professor Chiedozie Ngozi Egesi, the management and staff of National Rural Research Institute Mudeke, I wish to thank everyone who has made this outing a very huge success. Our appreciation goes to all our esteemed invited guests, our keynote speakers, list speakers, our partners, just to mention a few: RITA, Air Consulting, donor agencies, state ADPs, and all our senior colleagues who have exercised patience to be with us up to this moment. I want to say thank you, and may the Lord bless you indeed. So in the last 2 days, we have critically assessed our progress, celebrated our achievements, and charted your contributions, whether in presentations, discussions, or strategic planning, have been very invaluable. This meeting has reinforced that our strength lies in collaboration, innovation, and our shared commitment to agricultural research and development. The goals we have set are ambitious, but really achievable. And I'm confident that with the dedication and expertise in this group, our research scientists, we will surpass them. Then what are the take-homes from this outing? Number one, we have set up 2 committees, and I think the third one has just presented their report. That's Communicate Drafting Committee. We have set up Proposal Screening Committee and Report Review Committee. And I will mention the components of the 2 committees for their information and also quick attendance to the responsibility that have been assigned to them. For the Proposal Screening Committee, I have my humble self as the chairman, Dr. B.C. Okoye as the secretary, Dr. C.O. Amadi as member, Dr. T.J. Onyeka, member, and Dr. Eileen Ayebuna, member. For the Reports Review Committee, we have Dr. O.N. Eke Okoro as the chairman, Dr. Miriam Maza as the secretary, Dr. Marcel Oriocha, member, Mrs. Blessing Ukeje, member, Dr. Solomon Afape, member, and Dr. Innocent Onyekwere as members. The Proposal Screening Committee We commence immediately from Monday, and as much as possible, we prioritize proposals, but we try to accommodate every scientist. We did same in 2023, 2024, and by the grace of God, in 2025, shall follow the same pattern. 2, the executive director at the management have promised prompt release of funds to facilitate research activities. 3, for collaboration, we shall maintain existing collaboration while identifying productive partnerships and leverage on them. God, the Holy Spirit. God bless you.
Please, can we kindly just wait for the closing prayers? And I want to quickly call on Dr. Ms. Helen Anyebulam to close us.
In the name of the Father, and the Son, and the Holy Spirit. Our Heavenly Father, we want to thank you especially for being with us all through our deliberations. In this 2-day activity we have had, our Lord and our God, we thank you for our visitors you brought safely. Lord, we thank you for all the presenters. Thank you for all the organizers. Our Lord, we thank you especially for our executive director. Thank you for the wisdom you have given us and peaceful execution of all that we plan to do. Lord, we have closed. We are not going out of your sight. We pray that your blessing will go with us to our various homes. For those that will be traveling later, grant them safe trip to their various destinations. All this and more we pray through Christ our Lord. Amen. In the name of the Father, the Son, and the Holy Spirit.
Congratulations, National Root Crop Research Institute.
When I think about the things that you've done, my imagination has turned to reality.